Hello everybody. Here's actually an interesting example. It's a little bit different from the ones that you might have seen. So there is actually three blocks that are together or separate, but they are stuck together. So let's say this one has a mass of 2 kilogram. This is 5 kilogram, and this one I'm gonna say 3 kilogram. Okay, and there's an external force. I'm going to say 30 Newton that is pushing on this block. I'm going to call this one number 1. I'm going to call this number 2. I'm going to call this number 3. Okay, and this is an interesting one. Forget about gravity or whatever. Just let's say these blocks are actually floating in space, and it says find interaction force between 2 and 3. So you need to find basically the interaction force between blocks 2 and 3. So basically you need to find this force here. Okay. Yeah. So how do we solve a problem like this? Okay. First of all, we have to pay attention that this 30 Newton pushes on the 3 kilogram, and the 3 kilogram pushes on a hole on the 5 kilogram and the 2 kilogram. So basically, the 3 kilogram is pushing on the 7 kilogram. Okay. Now the 3 kilogram is pushing on the 5 kilogram, and the 5 kilogram is pushing on the 2 kilogram. Okay. Now the force the 2 kilogram is pushing on the 5 kilogram is the same as the force the 5 kilogram is pushing back on the 2 kilogram. Now the same is for everywhere because of action reaction law. Okay. So how do we find the interaction force on this one? All right. First of all, we need to find the acceleration of this whole system. That might help us. All right. Okay, so we treat these three objects as one individual object. So we can say F is equal to the mass, and that's the total mass, times the acceleration, and that's the total acceleration for the whole system. And we're going this way, so that's 30 Newton is equal to the total mass, which is 2 plus 5, 7 plus 3, that's 10. And the total acceleration, we can find it divided by 10. By 10, so A total is actually equal to 3 meters per second square. Okay, that's good. Now the interaction force basically between 2 and 3, you have to find the object of interest. Now which one of the 2 or 3 is the object of interest? Let's see where the force is. The force is coming from here. So 3 is pushing on 5, and 5 is pushing on 3. So the object of interest is this guy. That's the object of interest, because everything is pushing on that guy. So if you want to find the interaction force between 2 and 3, just find the force that 5 is acting on, or the whole system, 3 plus 5 is acting on the 2. Okay? Now how do you do that? Force is equal to the mass of the object of interest, which is 3 times the acceleration. Well, the acceleration, you found it from here. So the force is equal to 2 times 3, and that's what? 6 Newton. Okay? So 6 Newton is actually the interaction between 2 and 3. So if I ask you what is the interaction between 2 and 3, this is it. What is the force 3 is pushing on 2? It's this. What is the force 5 is pushing on 3? Is this. So that's the interaction force. Now what if we want to find the interaction force between 1 and 2? So let's find the interaction force between here. Okay. Well, look. The 30 Newton is pushing on 3 kilogram, and the 3 kilogram is pushing on this whole thing. See that? So the object of interest now is what? is the 2 plus 5. So I can claim that the force is equal to mass of 2 plus 3 times the acceleration. The force is mass of 2 plus 3, 5 plus, that's 7 kilogram, and the acceleration is the same. And that's what? 21 Newton. And that's it for this problem. I hope this helps. Thank you.